Before we commence the session, I would like to give you a few instructions. Dear participants, please mute your audio and switch off your video throughout the seminar to avoid inconvenience. If you have any questions during the presentation, please type them into the chat box in your control panel. We will respond to your queries after the session. Thank you for your kind cooperation. It's my privilege to welcome today's resource person, Dr.
Dr.
P.
P. Jotaman.
I
I
request
request
Ms.
Ms.
D.
D.
Sridhar
Sridhar
Devi,
Devi,
lecturing
lecturing
department
department
of
of
Botany,
Botany,
to
to
introduce
introduce
our
our
resource
resource
person.
person.
A very good morning to one and all. I felt very happy to introduce our most valued resource person of the day, Dr. P. Jyoti Madam. Present, she was working as a lecturer in Government Polytechnic College, Nalgonda. Madam completed her post-graduation in Usmania University from Organic Chemistry in 2011. She had achieved UGC JRF NET in December 2011. Later, she had selected as a scientific assistant in Andhra Pradesh Forensic Science Laboratories in March 2012. In 2012 October, she had selected as a lecturer in chemistry in Polytechnic College. Since then, she continued this profession. She had communicated 3 international papers as a first author, including 2 in Journal of Inorganic Chemistry Communications and 4 international papers as a second author. In year 2022, April, she had awarded with doctorate from Usmania University in the subject of chemistry. Her research interest of topics includes Kif bases and their metal complexes and evolving their biological activities includes DNA binding, incision and cytotoxicity, etc. Thank you, madam.
Thank you, madam, for your nice introduction. Jyoti, madam, please take over the session.
Okay. Thank you, madam, sir, for your kind introduction to me. Good morning to one and all who are there in the meeting. And today I would like to share my own research work that is also as a part of current trends and recent advances in chemical sciences and life sciences. So I would like to yes, this is. Share my own research work that is about synthesis, characterization, biological activities of metal complexes of She-based ligand. First, uh, the whole topic will be explained in detail by taking 4 chapters like introduction, what are all the importance that She-bases and metal complexes have, and experimental, how can we prepare those metal complexes and the She-based metal complexes, She-based metal complexes, and in the result and discussion part we'll discuss about how to characterize them and what are all the applications do we have by these metal complexes can be explained in the biological activity of these complexes. Right. In the introduction session, what are Shib bases? Shib bases are the organic compounds having azomethane or imine group, particularly formed by the condensation reactions of amine and carbonyl compounds in carbonyl, ketone, and aldehydes. And why should we prepare these Shib based metal complexes? These are having various applications in various fields, and of course, their preparation is also very simple to prepare them. And so the applications includes it can be used as a catalyst, pigment dyes, polymeric stabilizers, luminescence chemosensors, She-bases, and She-bases can also act as a corrosion inhibitors for any metal electrolyte system, and also biolubricant activities. And it is to be found that uh, when they combines with transit but metal complexes metals, particularly transition metals, She bases have improved their are showing their enhanced activities. And why those ship bases are showing such properties means, particularly it has a imine group that has opportunity for the splendid biological activities such as antimicrobial, anti-tumor, herbicidal, cytotoxicity, DNA. And these chipbases play a decision role in enhancing the binding capacity of DNA via stacking interaction and in stabilizing the DNA double helix. Madam, may I know, am I audible?
Yes, ma'am.
Okay, thank you, ma'am, for your response. Yeah. DNA is the it is the target molecule for most of the anti-cancer therapies. So it is necessary to found a drug that interacts with the DNA in a main fundamental issue in life sciences. And artificial nucleases are found to have low molecular weight and less reactive conditions. The binding of these small molecules like our ship bases or ship base metal complexes to DNA is extremely useful in understanding the drug DNA interactions. These metal complexes can be interact with the DNA through a covalent mode or a non-covalent mode. Generally, it happens through non-covalent mode by electrostatic binding, groove binding, or intercalative mode of binding. Here, we have a cisplatin, which is a most effective anti-cancer drug that is being used in treatment for the various cancers. However, the side effects of cisplatin made a requirement to develop a new drugs with minimal side effects and a maximum curative potential. Then, what is the scope of the work? Of course, there are a brief survey of literature reveal that been not much work has been carried out on the chelating tendency of shebases derived from, especially we are taking the N-methyl thiosemicarbosides as a shebase and uh, N-methyl thiosemicarbosides and salicylaldehyde with a bivalent transition metal ions. And metal complexes of shebases derived from substituted salicylaldehyde and N-methyl thiosemine. Particularly, we are taking substituted salicylaldehydes and N-methyl thiosemicarboside. Salicylaldehyde as a aldehyde group or aldehyde group means a carbonyl compound, and N-methyl thiosemicarboside has a amine group. So that these two components combines together or condense together to give a sheet base. And in view of the above and present work, I focused on design, synthesis, characterization, and biological activity and DNA interactions of metal complexes. Particularly in this session, we are taking cobalt 2, cobalt 2 as a metal and derived from nitrogen, oxygen, and sulfur are donors, donor bases of N-methyl thiosemicarbazole. Now, coming to the preparation of the ship bases. The ship bases preparation is very simple. It can be prepared by reflexing the equimolar amounts of N-methyl thiosemicarboside and substituted salicylaldehyde in methanolic solution for 4 hours at 70 to 80 degrees centigrade. And the reaction development is extent of reaction can be monitored by, of course, TLC. The obtained yellow color crystals or dark yellow color crystals were collected after cooling to room temperature, and the resultant product was recrystallized from the methanol. These are the some of the ship bases I have taken. This is the 2-hydroxy 5-bromo salicylaldehyde, and this one is N-methyl thiosemicarboside, and these two condense together and means a reflex for 5 to 6 hours to form a 2,5-bromo 2-hydroxybenzidine hydrazine N-methyl carbothiamide. Particularly, this is the scientific name, IUPAC name. And here we have taken another kind of salicylate, another substitute. Here we have taken, we are chloro substituted salicylaldehyde, and the N-methyl thiosemic carbazide remains same. Here we'll get the shibase of chloro substituted, that is 5-chloro 2-hydroxybenzylidine hydrogen N-methyl carbothioamide. And here I have taken ketone, argohydroxy acetophenone, argohydroxy acetophenone, and N-methyl thiosemic reflex to undergoing reflex to give a 2-hydroxyphenylethyridine hydrogen N-methyl carbothioamide. The earlier ones are formed from aldehydes, and here I have taken the acetophenone, that is formed by carbonyl compound. Now this is about formation of shibase ligand, and we'll move to the how metal complexes are prepared. There are two kinds of metal complexes. One is binary metal complex and second is ternary metal complex. Binary metal complex in the sense there is metal and there is only one kind of ligand, that is shibase. Ternary metal complexes are metal, shibase and another ligand. Two kinds of ligands are present in ternary metal complexes. Binary metal complexes preparation is as simple as shibase metal complexes, like taking methanolic solution of metal chloride solution and methanolic solution of shibasing, mixing together and reflexed at 60 to 80 degrees centigrade for 2 to 3 hours. The prepared the metal complexes will be precipitated out on cooling, and the colored solid products obtained were filtered and washed thoroughly with methanol, petroleum ether, and dried in vacuum over anhydrous calcium chloride. In ternary metal complexes are synthesized by mixing the 1:1:1 ratio of methanolic solution of shibase and methanolic solution of metal chloride and the methanolic solution of another ligand. Like I have taken 110 phenanthroline in one complex and bipyridine or ethylene diamine or oxalic acid. With these ligands, I have prepared so many components of ternary metal complexes. And these three are together 1:1, 1:1:1 together or mixed together with the constant stirring and and reflexed for 2 to 4 hours at 60 to 80 degrees centigrade on water bath. On cooling, the colored, whatever the colored solid metal complexes are precipitated and filtered and washed with cold methanol and dried in the vacuum. Yeah, like this is the, yeah, we can see in the diagram. This is the shibase. This is I have taken a bromo substituted shibase ligand, salicylaldehyde, bromo salicylaldehyde, and N-methyl thiosemic carbazide. This is the shibase ligand. This is first 1:1. Here for complex 1, I have taken 1:1 ratio of shibase and the metal chloride to form a metal complex with only one shibase ligand. So, as shibase ligand is a tridentate, oxygen, nitrogen, sulfur, and fourth one is coming from the water. And this is the second complex that I have been prepared by taking 1:2 ratio of metal chloride and the shibase ligand. So, this is metal, and this one is one shibase, and this one is the another mole of shibase. Same shibase, but taken in 1:2 ratio. So coordinated with like octahedral manner. So these 1 and 2 are binary metal complexes particularly, and here 3 and 4 are ternary metal complexes. We can see, including in addition to the shibase ligand, there is another ligand. Here, this is the shibase ligand, and this one is ethylene diamine. And this is the shibase ligand, and this one bipyridine is the another ligand. So these are ternary ligand. So here I have taken 1:1:1 ratio of shibase ligand, cobalt chloride, and ethylene diamine, so that it will prepare this kind of ternary metal complex. Here also 1:1 ratio, 1:1:1, 1:1 ratio of She base, cobalt chloride, and dipyridine. So it forms a ternary metal complexes. And this is these are the another complexes formed by taking another She base ligand, that is particularly chloro substituted She base ligand. I mean, the thiosemic carbazide is fixed. The keto carbonyl group only changes. Like chloros, here I am taking chloro substituted salicylate. These are all the complexes formed by reflexing with metal complexes with this She base ligand. This is 1:1 ratio, 1:2 ratio, and this is these two are the ternary ligands. Here I have taken oxalic acid as a ternary ligand. And this is these four are other these four are also another kind of complexes that are being formed by taking another type of She base ligand. Third one, I mean, keto orthohydroxyacetophenone is a aldehyde here, carbonyl group here. Complex 9, 1:1 ratio, 1:2 ratio. Here 1:1:1 oxalic acid. This is bipyridine, 1:1:1 ratio. These are all the complexes that we have seen earlier, their structures, I think. Now, how to study the DNA binding studies? DNA binding studies have been studied by using three techniques: UV visible absorption spectroscopy, fluorescence quenching titrations, and viscometric titrations. In UV visible absorption spectroscopy, it is recorded in spectrofluorometer in the buffer of TAE solution of pH 7.2 and 25 degrees centigrade. The more important one is here the concentration of the complex is fixed. That is at 10 micromolar, and successive increments of ctDNA concentration will be varied. That is from 0 to 10 micromolar. Will be discussed later, that is in biological activities, clearly. This is just how to do the absorption spectroscopy. Fluorescence quenching titrations. Fluorescence quenching study generally recorded in spectrofluorometer. Here the concentration of the DNA and EB, ethidium bromide, is fixed. Concentration of DNA is we are taking at 125 micromolar, and ethidium bromide is 12.5 micromolar, and the complex concentration is varied from 0 to 60. Earlier, complex concentration is fixed in absorption spectra, but here complex concentration only varied, and we're taking several ways. Viscosity titration, viscometric titrations generally performed on viscometer, Ostwald viscometer. Here also the concentration of DNA is fixed and the complex concentration is varied from 0 to 100 micromolar. This is the DNA cleavage study. For the cleavage study, I have generally we'll use agarose gel electrophoresis technique, and done by two methods: oxidative cleavage and photolytic cleavage. The oxidative DNA cleavage is monitored by treating the supercoiled DNA with metal complexes and H2O2, oxidative in the sense in presence of hydrogen peroxide. Commonly followed by dilution with TAE buffer, and it will be adjusted to the 16 microliters, and the samples were incubated at 37 degrees centigrade for 2 hours. After it will be photographed under gel electrophoresis. In photolytic cleavage is monitored by plasmid, treating the plasmid supercoiled 330 DNA with varying concentration of metal complexes, followed by dilution with buffer solution to a total, as usual, 16 microliters. Here, the variation is the samples were incubated. After incubation, these have been irradiated by long UV light. Photolytic in the sense in presence of UV light, oxidative in the sense by adding hydrogen peroxide. Cytotoxicity. Cytotoxicity is the study that is used to know the anti-cancer activity of the prepared ones. It is examined, the, the metal complexes were examined for these activity on especially HeLa and MCF cell lines using calorimetric assay MTT assay. Here also different concentrations of test compounds were added to culture media. After 48 hours of incubation, the cells were washed twice with phosphate buffer solutions and MTT solution was added to each well, and then plates were allowed to incubate at 37 degrees centigrade for 3 hours. At the end of the incubation time, the precipitates are formed as a result of reduction of these MTT to the formation crystals by mitochondria, which is present in our cells. The optical density of these crystals in DMSO solution were measured at 570 nanometers on microplate reader. Here, the percentage of inhibition, that is a principle that is 100 into control minus treated by control. And one more thing that is also important for cytotoxicity is IC50. IC50 is the parameter. It is a parameter for the cytotoxic study. Can be defined like the concentration of the compound that is required to inhibit the cell growth by 50% is IC50 value. And antimicrobial activity also I have done like by taking and on bacterial strains and fungal strains. For bacterial strain, I have chosen the gram positive of Bacillus subtilis and Streptococcus aureus, and gram negative of it's E. coli and Pseudomonas aeruginosa. Cultures of test organisms were maintained in nutrient media and then subcultured into petri dishes before to the testing. The fungal organisms for antifungal testing, I have chosen the fungal strains of Fusarium oxysporum lycopessicum and Fusarium raceme, and the procedure is same. Only the difference is here bacterial strains and antifungal strains. So, coming to the third chapter, which is most important one, that is the characterization of prepared ones, either ligands or metal complexes. How to characterize them? How can we confirm that how the particular compounds are formed by our procedures? Uh, these can be characterized by using several techniques like elemental analysis, NMR, proton and C13 NMR, mass spectra, IR spectra, electronic spectra, magnetic moments, and TGA, etc. The properties of ligands, physical properties like they are stable to at room temperature and non-hygroscopic itself. And coming to solubility, they are soluble in organic solvents, all like methanol, esternitrile, chloroform, dichloromethane, DMSO. Whereas they are only soluble, whereas metal complexes are soluble in DMF and DMSO, but not both, but both are insoluble in water. Yeah. HNMR, proton NMR spectrum, coming to proton NMR spectrum of the ligand. This is the NMR spectra of the ligand. NMR spectra clearly it tells about the confirmation of the, confirms the formation of a Shib-base ligand by showing different types of protons present in the Shib-base ligand. So we can interpret this Shib-base ligand such. This is the aldehyde group, and this one is the thiosemicarboxide group. The main indication of formation of Shib-base ligand is the presence of azomethyl proton, that is CH proton. If we find a CH proton in the NMR spectrum, that confirms the formation of a Shib-base ligand. that CH proton is clearly absorbed at 10 point around 10.3, it is 10.3 ppm, and this 11.5 ppm is attributes to this OH hydroxyl proton, and these three signals attributes to the benzene protons, and these two attributes to the these amine protons, and this one is clearly high intense peak is very clear, that is by methyl protons, and this one is TMS proton, which is a solvent in standard in proton NMR spectra. C13 NMR. C13 NMR spectra also giving more relevant data regarding the formation of C-base ligand by giving different kinds of carbon atoms present in the compound. That is coming to the interpretation of this spectra to this ligand. And this high intense peak attributes to the methyl, and there are one two here there are six kind of carbon atoms for aromatic ring. These six are attributes to the aromatic ring, and this one is for methyl, and only two are remain, this carbon and this carbon. This is the thioketocarbon, this one, and this one, this is the thioketocarbon, and this one is the azomethyl carbon, CH, that is at around CH carbon is around 155 it is. So it clearly tells about the conformation of the formed C-base ligand. Mass spectrum, as usual, mass spectrum is also giving relevant information regarding the conformation of the formation of compounds by taking the criteria of their molecular weights. Here it is the molecular ion peak, that is at the molecular weight of C-base ligand is 286. So being a molecular ion peak, it is observed at 286 only. Clear peak such a. This is a mass spectrum of the one of the complex, that is 1:2 complex, 1 cobalt and 2 ratio of C-base ligand. Around M plus 1 peak, 631 it is around. The molecular weight of this one is, the total structure is 630. I got it 631 M plus 1 peak. So it clearly tells, it clearly gives the information regarding confirmation of this process. And this is also another mass spectrum. Here also, this is a ternary ligand. This is the data which is showing all the obtain all the mass data of all the complexes. In all the cases, the calculated mass values are almost agremented with the obtained mass values. Like it may be a molecular ion peak, it may be M plus 1 peak, or it may be M plus K peak, or M plus sodium peak. But all are in good agreement, so that we can confirm that they are formed. Yes. FTIR spectrum. FTIR spectrum is the most important spectrum that gives the information about the coordination mode of C-base ligand, or functional groups of C-base ligand coordination mode. And what are all the binding sites of the C-base ligand that will bind to the metal complex? Sorry, metal. Like this is the IR spectrum of the chlorosubstituted C-base ligand. If we observe clearly, there is an intense peak. There is a intense broad peak which is observed that attributes to the hydroxy group, OH group, and there is a sharp peak that is around 1750, that is attributes to the C double bond N, C double bond N group, and there is also a group of strong peaks that observed at this 1200 region, that is a thioketo groups. If we see in the what are all these conditions in the metal complex, we'll see. Let us see. And those broad banks will be disappear in the metal complex. If you see here, you can see clearly, or it may be shifted or altered. The broad band appeared in the Schiff-base ligand was disappeared in the metal complex, clearly indicating that the OH group is involves in the formation of involves in the coordination. Hmm. So oxygen is the one of the donor side, and the band at 1700 is also shifted, slightly shifted to 10 to 20, 10 to here also, so 17, around 1780, but here he, sorry, here it is 1720 only, and it is altered or it is shifted from 10 to 20 centimeter inverse. Is also giving us the information regarding that nitrogen is also involving in the coordination. That means coordination means nitrogen is linked to the cobalt metal. And if we see clearly, the sulfur, the C double bond S group was also varied, that is 1250. Here we are seeing at 1250, but in the Schiff-base ligand that is at 1200 only. Means varies in the sense the C double bond, that sulfur also involved in the coordination. Hence we can confirm that in the prepared Schiff-base ligand there are three donor sites like oxygen, nitrogen, sulfur. This is a, we can confirm that this is a tridentate ligand, oxygen, nitrogen and sulfur. And these are the sum of the IR spectrums. This is the total table which is giving information about IR frequencies of all the Schiff-bases and metal complexes. See here, in the Schiff-base metal complexes, there is no band for metal oxygen, means, or metal nitrogen, metal sulfur bonds. But here, in the metal complexes, there are the peaks that are for metal to oxygen, metal to nitrogen, and metal to sulfur. Here is also one of the indication that a metal complex has been prepared. And Schiff-base, this is also one of the Schiff-base ligand. There is no metal nitrogen, metal oxygen, metal sulfur bonds. Here also there is no bonds. But here, yes, it is there. Yes, metal oxygen, metal nitrogen, metal sulfur bonds are there. Of course, they are low intense peaks, but helpful. They'll be helpful in interpretation or formation of the metal, confirms the formation of the metal complexes. This is the elemental analysis. So 37.3 is the observed elemental analysis, and the calculated, the percentage of carbon in the Schiff-base ligand is 37.6 according to our calculation. But I got about 37.3. It is very close to the calculated one. So hence we can also confirm from here also we can confirm the formation of the particular ones. And electronic spectra, ESR spectra, that really gives very much helpful in giving the information regarding the geometry of the complexes, that is shape of the complexes. This is the Schiff-base ligand, ESR spectrum of the Schiff-base ligand. We can see this structure here. This is the ESR spectrum of the metal complex. If we see clearly, there are only transitions that are present in 200 to 400 region, maybe attributes to the charge transfer transitions. But if you see in the metal complex, there are the peaks that are present in the around 500 to 600 or 700 region, with a broad peak, indicating that there are dd transitions are present, that particularly giving 500 to 600, 500 to 500 to 700 nanometers, indicating the tetrahedral geometry. Because of this band is particularly quartet A to G, F to quartet T1G, F. This is the indication of the tetrahedral geometry. But if you see other complexes, this is the 1:2 complexes, oxygen, nitrogen, sulfur. Here, oxygen, nitrogen, sulfur, 1:2 complex. Imaginary, we can imagine that being a six donor positions. We can imagine that it is octahedral complex. But will be clear by the ESR spectrum that. The peaks that are observed at 200 to 400 nanometers are due to the charge transfer transitions. But here, 700 to 800, there is a broad peak here also. This is the ternary ligand, particularly this is the binary ligand. Here, this is the ternary ligand. In these both cases, we are seeing the peaks that are present at 700 to 800 region. Clearly tells us the octahedral geometry is there, because in octahedral geometry only that bands are possible um, because of their spin allowed dd transitions of quartet T1G F to quartet T2G F. It is an characteristic of octahedral geometry. But if these are not the case in the in ship-based ligand. There are there are no bands beyond 400 degrees centigrade. Tells about there is only charge transfer transitions, CT transitions, that are possible in ship-based ligand. But here, uh, by by coordinating with transition metal, there is a possibility of dd transitions. Those dd transitions also, among them also, if it observed in 500 to 700, that is about tetrahedral geometry. But in 700 to 800, that attributes to the octahedral geometry. So that we can uh, we can we can further um, mm, confirm their geometry by observing the magnetic momentum, particularly giving magnetic momentum of 4.8 magnetons, also suggesting that octahedral geometry. Because if a magnetic momentum is 4.8, the unpaired electrons would be 3 electrons. 3 electrons are possible in cobalt. When it is possible, cobalt plus 2. If it is a weak field ligand and cobalt plus 2 case only, there are 3 unpaired electrons will be present. Exactly, we got the magnetic momentum of 4.8 more magnetons only. Clearly telling about there are cobalt is in plus 2 condition. This is a weak field ligand, and it is having octahedral geometry. So that we can propose their structures like this. This is the 1:1 complex. So, and showing the bands around 500 to 700 nanometers, so that we can propose only tetrahedral geometry here. Octahedral geometry, 1:2 complexes, and these are the ternary metal complexes. Here also we'll propose tetrahedral geometry only. These are also some of other complexes. Same. If it is 1:1, it will be in tetrahedral geometry. 1:2 or ternary metal complexes will be showing octahedral geometry. And another important spectrum that will gives the thermal stability of the metal complex, that is TGA, thermogravity gravic analysis. thermogravimetric in the TGA spectrum. If you see the TGA spectrum of the complex, there is a weight loss below 100 degrees centigrade is about it is about to have a presence of water molecule is there in the ligand. Particularly, it is there in the 1:1 complex. But there is a weight loss that is observed below 200 degrees centigrade attributes to a partial disintegration of the Shibase ligand, and the weight loss that is observed after 300 nanometers is complete degradation of the Shibase Shibase ligand around the cobalt metal. So that we can confirm upon by changing temperatures there is a variation in the weight loss. Now we are coming to they're evolving their biological activities of the prepared ones. Particularly, we are in the first we are taking the DNA binding study. In the till now we have confirmed that the formation of the metal complexes, Shibase ligand, and their geometry. Now we are moving to the next step, that is evolving their biological activities. Especially here, first we are taking by DNA binding study. DNA binding study has been achieved by three tests: absorption study, quenching study, and viscometric titrations. Absorption study, as we know, we have discussed in the um, materials and methods section. These are performed with fixed complex concentration and varying the ctDNA. Means variation in the sense, while measuring the absorption, equal increments of ctDNA were added to both complex solution and reference solution to eliminate the absorbance of ctDNA itself. Upon addition of increasing amounts of DNA, the intensity of pi star transition band of complex is decreased by 3 to around 12 percentage. Particularly hypochromism in the sense a downshift. There is a absorption intensity is coming to downshift. That is, hypochromism is observed in the absorption study, and also with a slight redshift, that is 1 to 7 nanometers, will be clear in the by seeing diagram. 1 to 7 nanometers. Of course, these binding constant values will be evaluated by this formula, and here binding constant is the calculated from slope to intercept ratio. This is the absorption spectrum of the three metal complexes. This is the complex 1, complex 2, complex 6. Here, this dotted one is absorption spectra of the complex in the absence of the ctDNA. In the absence of ctDNA, it is there in the top. Yeah, upon addition of DNA to the metal complex, the absorption intensity is being decreasing. So from here to this side. Upon addition, upon increasing the concentration from 0 to 10 micromolar, increasing 0 to 10 micromolar means by adding 10 micromolar, the intensity is decreased to this much. The absorption intensity is decreased this much. This is downwards. This is coming to downwards, means it is showing hypochromism. Of course, there is a slight absorption. Wavelength is shifted to the higher. The wavelength is shifted to the higher ones, slightly longer wavelength. That is a bathochromic shift, and hypochromism is it is a clear tool of the metal complex is linked with DNA through a intercalation mode of binding. If it is hyperchromism, that is a groove binding, another kind. Now we are seeing only hypochromism and bathochromism. Hypochromism is the clear tool of intercalation of mode of binding is present between the DNA and the metal complex. And now, what is the intercalation mode of binding? Intercalation mode of binding is the aromatic moiety of the Shibase ligand or metal complex will be interacts or intercalate into the DNA base pairs. This would be possible when it has appropriate size of DNA base pair, the gap that is present in the DNA base pairs. Here also we can see hypochromism and bathochromic shift. These are all the binding values, constant values of the ligands and Schiff bases. Now another kind of study, that is a fluorescence quenching study. It is that is absorption technique. This is the emission technique. And here the relative binding ability of the complex with DNA has been investigated by ethidium bromide. Ethidium bromide is a weak fluorescent compound. In its HCl buffer, it shows a low intrinsic intensity due to quenching by solvent molecules. But upon addition of metal complexes to this EB bound DNA, uh, the fluorescence intensity EB bond can be quenched or decreased by as decreased is observed when we add a metal complex to this EB bound DNA. The relative binding constants of these complexes have been estimated by Stern-Volmer equations. These are the emission spectrum of the EB bound DNA. This dotted line represents the EB bound DNA, and these color ones are represents the addition of metal complex to the EB bound DNA. Upon addition of metal complex or a base to the EB bound DNA, what happens? The intensity is being decreasing. That is, hypochromism is observing. These are also emission spectrum of other metal complexes. This is the table that is representing Stern-Volmer quenching constant values of all the complexes. Viscometric titrations. Viscometric experiments were carried out. Uh, we know Ostwald viscometer, and here also DNA concentration is like quenching or emission technique. DNA concentration is kept constant, and the concentration of complex is being increased gradually. The flow time measurement was repeated 3 times for the same complex to get an average flow time. Here, to study the effect of DNA binding on the viscosity of the complex, the plot was made between neta by neta naught to 1/3 and the ratio of concentration of the complex to CTDN. Here, the neta is the viscosity of DNA in the presence of complex, and neta naught is the viscosity of DNA alone. This is here we can see, and this is the reference EB, ethidium bromide. Viscosity of ethidium bromide, viscosity of the DNA is being increasing by adding with complex. Here, from here to here, you can see, observe. Here DNA concentration is fixed. One thing we are changing is only metal complex. Upon addition of metal complex, from at 0 here at 1 millimolar, this was the viscosity we are observing. At 2 millimolar, this was the intensity viscosity. That means viscosity is being increasing by the addition of metal complex to the DNA, because the case is by adding metal complex to the DNA base phase will be elongated. Length of the DNA will be elongated. Hence, the viscosity also increases. Now, coming to the DNA cleavage study, generally we use gel electrophoresis technique, done both by oxidative and photolytic cleavage methods. Here the sample solutions were incubated for 2 hours. We discussed in the materials also, for 37 degrees centigrade, and followed by mixing with bromophenol. The electrophoresis was performed at 70 volts for 45 minutes by loading mixed samples in the wells of 1% agarose gel, which was placed in TAE buffer containing tray. The resulting gel was stained with ethidium bromide and before the images were taken under UV light using gel documentation. The cleavage ability of the complexes against DNA is estimated by the conversion of DNA from form 1 to form 2 to and form 3. Here, what are form 1, form 2, form 3? Form 1 is a supercoiled DNA. If the cleavage takes place on one strand of DNA, that will be form 2, mean liquid form. And if the cleavage is takes place on both the strands of DNA, that will be form 3 in or linear form of DNA. In general, form 1 migrates faster, form 2 migrates slower, form 3 will be in between them. These are the photographs I got an oxidative cleavage of the metal complexes. Here there are no bands, there are no form 2 bands for 1 and 2 lines, because 1 and 2, 1 is only DNA and 2 is DNA plus H2O2. There is no metal complex. Telling us the catalytic role of metal complexes in cleavage in the DNA. Like oxidative in the sense, in the presence of hydrogen peroxide, where hydroxyl radical is this hydroxyl radical will start the mechanism. Photocleavage, photochemical, photolytic method. In the photolytic method, we'll irradiate it with the UV light. Here the starter is oxygen radical, and if you see this photograph clearly, there is no band at one line. There is in under form 2, because one indicates only DNA control. By adding complexes, we'll observe the form 2 also, telling us the information about metal complexes or cleaving the DNA very nicely. Coming to the antimicrobial studies, antimicrobial activities were performed. Antimicrobial in the sense antibacterial and antifungal. I have chosen different cultures of bacterial and fungal strains. These red pillars indicating that the study on Bacillus subtilis, green one Streptococcus aureus and E. coli, and this blue line is Fusarium aeruginosa, and these two, pink and yellow, are some fungal strains. When we see, this one is the standard, showing highest peaks, means standards. Like, for bacterial strain, I have chosen the penicillin as usual. For fungal strains, I have chosen the standard of ketoconazole. As usual, standards are showing highest activity. But if you see the activity of our prepared ones, they are almost, especially in the antifungal, they are almost related to the standard ones. So in pink lines you can see they are almost related to the standard ones. Standard. This backline is indicating standards, and this is the complex. This one is the complex 3, complex 2, complex 1. This one is the ligand. But in all the cases, the Shibases are showing less activity than metal complexes, telling us about metal complexes are having more activity than the Shibase ligand. We know. In general, antimicrobial activity is evaluated by inhibition of zone values, inhibition of the cell growth, inhibition millimeters of the compounds. This table is giving clear information about the zone of inhibition values of antibacterial activity of all the metal complexes that I have been prepared. Here you can choose. Here you can see. These 4 are the bacterial strains. This one is the penicillin, which is a standard. But you can see these are all the values or readings I got. that are almost nearer to this one. 8 almost. Particularly this complex is showing 8 means here standard is 10, almost nearer. This is the zone of inhibition values of antifungal activity of metal complexes. Yes, this L indicates the ship-based ligand, and these four are the metal complexes. And this one is also ship-based metal complexes, ship-based metal complexes. You can see here 12 and 11. So metal complexes are almost, of course, this particular complex is showing almost most active. That is as same as standard. What a ketoconal is expressing is same by this component. It is also showing 12 millimeters. Means we can say that the metal complexes are the prepared ones are this particular metal complex is having high activity, high antifungal activity as standard. Now coming to the cytotoxic activity, which is a very valuable tool in the screening of chemotherapeutic agents. Um, mm, Particular in this I chosen HeLa and MCF cell lines, and of course the technique is MTETSA in common standard of cisplatin only. The cytotoxic activity of metal complexes depends on the capability of this metal complex to intercalate with the DNA, and which leads to failure of its function, that leads to the cell death, so that the cell the cell growth will be inhibited. And there is, as we know, the results were analyzed by IC50 values that comes from the curves of cell variability. According to the result, as the compound concentration increases, the viability is being decreases. We'll see clearly in the diagram. The higher cytotoxicity of the complexes is because of higher binding ability of the metal complex with DNA. This is the diagram, which is a plot made between percentage of cell viability and the concentration of the complex. You can see this is a complex concentration of 20 micromolar, 80 micromolar, 60 micromolar, and 100. Sorry, 100 micromolar. As the concentration of the complex increases, what we can observe is cell viability is decreasing like this. As the concentration of the complex increases, you can see in the complex 2 also. As the concentration of the complex increases, the cell viability is being decreasing, means cell inhibition is increasing, means the cell is undergoing death by increasing the concentration of complex. This particular is on MCF cell lines, and this is the table which is giving IC50 values of all the components. The lower the ISO50 values, and the higher will be the activity. We can see what are all particularly this compound has 42.78 micromolar, that is cisplatin 41, so almost nearer to the standard ones. This is and this one is the HeLa cell lines. Here also the same. Smaller the IC50 value, greater the activity will be. So here 29 and 44. 29. Oh, here this molecule only has a lower value. 44 means it is highly active on MCF7 cell lines. Means we can say that this particular compound metal complex is having more activity in DNA binding studies, cytotoxicity, and also in antimicrobial activity because of this planar molecule. You can see cobalt ligand 2 octahedral complex with 1:2 ratio of metal complex and a She-based ligand. Uh, Octahedral molecule, particularly Plenarity is the reason for more activity. Okay, these are all the activities, and here are the conclusion parts. And the analytical and the spectral data suggesting that all the complexes are adapting octahedral geometry except particular ones which are formed by 1:1 ratio, where only one base and one water molecule is there. And the binding interactions results obtained through absorption titrations, fluorescent benching, and viscometric studies reveal that the complex bind to DNA mainly in intercalative mode. As we know, intercalation means the DNA aromatic moiety of the complex will be intercalates in between the DNA base pairs. The DNA cleavage study of the complex revealed that these complexes can effectively cleave supercoiled DNA into liquid form and linear form in the presence of hydrogen peroxide and also UV light. Compared to Shibase ligand, the complexes exhibited good antimicrobial activities against the bacterial and the fungal strains. Here, uh, we can think over that, like why metal complexes are giving more activity, showing more activity than Shibase ligands is by connecting or by coordinating with a metal complex, the chelation will be increases. If the chelation is increases, the polarity will be decreases. The polarity is decreases, the lipophilicity is increasing. Lipophilicity is the factor that will really increase the antimicrobial property, in the sense like lipid layer of cell membrane allows only lipid soluble molecules into it. Like by increasing the lipophilicity, we can increase the activity. This lipophilicity will be increased by chelation. In the sense, hence, metal complexes are showing high activity than Shibase ligand. The, cyt- the cytotoxicity activity of these metal complexes against and against MCF7 and HeLa cell lines also showing complexes work better in cell damage, as we see in MCF cell lines, that is almost nearer to standard drug. These are all the papers published, but the research has to be continued on this work because they're having a more biological properties. Now it's time for question and answers. I would be very happy by taking questions.
Thank you, madam, for your wonderful presentation. We are grateful for the time and effort you took to share your thoughts and knowledge with us, ma'am. Dear participants, please type your questions in the chat box or you can interact with madam and clarify your doubts. Madam, there is a few questions in the chat box.
Okay, I will see, madam. Let me see. Madam, madam, what relation with it IC50 values with cytotoxic activity? IC50 value is the parameter that it really helps to know about cytotoxic activity. Means the concentration of the compound that is required to inhibit the cell growth by 50%. Hence, it is IC50, 50% of cell growth, 50% inhibition of cell growth. Ma'am, what is bathochromic shift, ma'am? Yes, a nice question. Bathochromic shift is wavelength is shifting to the longer wavelength from we observed in the case of absorption spectra. If we see in absorption spectra, upon addition of a metal complex to the DNA, the DNA is showing hyperchromism And bathochromic shift means it is shifted to the shifting of wavelength to higher wavelength, lower to higher. Means a right side. The signal is turning to the right side. That is a bathochromic shift. Why viscosity is increasing, madam? Thank you. Very good question. Viscosity is being increasing by uh, when we add a metal complex to the DNA, supercoiled DNA, it will intercalate with the, it will definitely intercalate with the supercoiled DNA. Hence, there will be an increase in the length of the DNA. By increasing in then, there will be definitely increase in the viscosity. Any more questions?
Hope there is no further questions. We will move to the next section.
Thank you, Jyoti, for accepting my invitation.
Oh, thank you very much, coordinator madam, and my dear friend, for approaching me to take this session. It's my honor to take this session.
Thank you, thank you. Okay, next. Next turn, Kelly.
Now it's time for paper presentations. I request.
Thank you, madam. Can I leave, madam?
Okay, ma'am, you can do it.
We will move to the next session.
Okay, can I leave, madam?
Okay, okay, madam.
Okay, thank you, madam.
Thank you, Jyoti.
Okay, thank you.
Now I request M. Swati, resource scholar at Usmania University, to share your paper presentation on the topic synthesis, structural and characterization of DNA interaction and anti-tumor activity of metals. Madam, please start your paper presentation. I request N. Jyoti Madam, lecturer in chemistry at Government Degree College, Chavela, and research scholar at Usmania University. Madam like to share paper presentation on the topic studies on mononuclear cobalt, nickel, copper, and complexes of 5-trifluoromethyl 2-methoxybenzyamine. Madam, please start your paper presentation.
Are you seeing my PPT, madam?
No, madam.
Yeah, it is visible. Uh, okay, okay.
It's we are see to visible my PPT.
Yes, ma'am. Yes, ma'am.
Okay, ma'am. I am N. Jyoti, assistant professor of chemistry, working at Government Degree College, Chevela. My topic is mononuclear cobalt-2, nickel-2, copper-2 complexes synthesis spectral characterization interaction study with nucleotide by in vitro biochemical analysis. My topic importance is ship bases are common ligands in coordination chemistry. The imine group of ship bases provides an outstanding performance in biological activities such as antibacterial, antifungal, antitumor, herbicidal activities. The transition metal complexes of ship bases are basically important of their raised biological activity, and also they make possible development of novel unique properties. And copper is an essential trace element for human being. For example, Paladivar pointed out the copper complexes are best alternative to cisplatin. Metal complexes can bind to DNA through non-covalent interactions such as electrostatic binding and groove binding, intercalative binding, and partial intercalative binding. The literature survey shows that the metal complexes reveal that the metal complexes show higher biological activity compared to their respective ligand. Because of this, the coordination reduces the polarity of metal due to the partial sharing of its positive charge with donor atom of ligand. Objectives in brief,
వాళ్ళు ఎవరో
then
పట్టించుకోవట్లేదు.
sir, listen my voice.
Okay.
Hello.
Ma'am, it's clear, ma'am. You can continue.
Okay. Objectives, sir. Synthesis of ship-based ligands and synthesis of binary copper-2, nickel-2, cobalt-2 complexes, spectral characterization, DNA interaction studies, and antimicrobial activity studies. Synthesis route of ship-based ligand. Hot methanolic solution of 5-trichloromethyl-2-methoxybenzyamine was magnetically stirred in a round bottom flask, which a dropwise addition of 3,5-difluoro different types of salicylate 1:1 molar ratio. The reaction mixture was defluxed at 50 to 60 degrees Celsius with constant stirring for 3 to 5 hours. The purity of compound was tested by thin layer chromatography. The result product was isolated, washed with petroleum ether and methanol. The ship bases were dried vacuum desiccators and over the NCSCl2. And the synthetic route of binary metal complexes, same similar to the hot methanolic solution of various estates by using to add it to the different types of ship-based ligands, 1 to molar ratio. The reaction mixture was defluxed 60 to 70 degrees centigrade for 3 to 5 hours. These by the reaction of monitoring and tested by using a PLC. These obtaining products were washed and filtered by using different types of methanol and ether. These are dried with a vacuum desiccator over the CaCl2. Spectral analysis. Characterization of ligands and their metal complexes. All the compounds are colored and stable at room temperature. The ligands are soluble in organic solvents like methanol, chloroform, acetone, DMF, DCM, and DMSO. The complexes are partially soluble in methanol, chloroform, were fully soluble in DCM and DMF and DMSO. The ligands and their metal complexes have been characterized by FTIR, NMR, MOS, electronic spectroscope methods. This is the NMR spectrum of my L1 ligand. This spectrum shows that 4 peaks. First, OH peaks we observed at 14.1210 singlet, and azomethane group we observed that 8.64. Aromatic protons we observed 7.54, 7.05. Methoxy group we observed that 3.93. This is the mass spectrum of my ligand. The mass to give the preliminary structure of mass of compounds, ligands, and metal complexes. This is the IR spectrum of my L1 and L2 metal complexes. L1 ship base shows that the L1 and L2 ligand shows the stitching frequencies 1622 and 1670. This peak we observe that azomethane peak. When it is upon complexation, the proton is deprotonated. The ligand of carbon is coordinated with the metal ion. And other peak we observe that OH peak we observe 3664. This upon complexation, this peak is disappear. The phenolic OH is coordinated with the metal ion. And other supported data we observe that the ligands and metal complexes, CO peaks we observed in metal complexes in the region of 1122 and 1125. And other non-bonded peaks also we observed that 400 to 600 centimeter inverse. This is the L1 and L2 and L3 metal complexes. L1 cobalt and L2 is the nickel and L3 is the copper complexes. This is the UV electronic spectroscopy of my complexes. It shows the two types of peaks. One is the 5 star and N5 star peaks. 5 star peaks, we observe that it is the indicated that aromatic peak, and N5 star peaks we observe that 343. This is indicating that azomethane peak. And other the non DD transitions we observed in the UV spectra. This is indicating that cobalt, majorly we observe that ligands and metal complexes major comparison. DD transitions shows that metal complexes, the N5 star and N5 star peaks we observed only ligands. ESR spectra of copper complexes. This is indicating that majorly ESR to give the unpaired electrons are present in metal complexes. Copper shows that these G parallel and G perpendicular G values. L1 ligand shows that 2.12 and 2.09, 1.43, and L2 also shows that 2.13, 2.01. This is indicating that the unpaired electrons present dx square y square orbital giving 2b1 as the ground state. And further, it is observed that G parallel values are copper complexes are less than 2.3. This is majorly covalent nature of metal ligand bond. And the next, DNA binding studies. The DNA binding studies of electron spectra, majorly it is the binding nature of metal complexes with DNA. It is the we observe that intercalative binding of metal complexes with DNA. The absorption titration experiment were performed with fixed concentration while varying the ctDNA concentration 0 to 10 mu. From the absorption data, the institutive binding constant Kb was determined for the plot DNA EF versus DNA. This is the equation using to calculate the Kb constant. DNA is the concentration of DNA is base pair, and EF, EB are the apparent absorption coefficients of the complex in the presence of DNA, free complex, and fully bound DNA complexes. Dotted line shows that absence of the complexes and presence of increasing of DNA concentration, the intensity of absorption spectra decreases. This is majorly indicating that intergalactic binding of metal complexes with DNA. These all are L1 and L2 cobalt nickel complexes absorption spectra. And fluorescence spectra, this is the fluorescence spectra of my complexes. The intergalactic binding nature between the metal complexes and ctDNA further confirmed by the fluorescence titration technique at room temperature. In order to determine the extent binding interaction between the metal complexes, ctDNA, the following equation is Stern-Balmer equation. This is the I0 by I is equal to 1 plus KSVQ. The emission spectra majorly EB DNA system. Arrows are shows that first dotted line is the EB and DNA. High intensity peaks of fluorescence emission spectra pinching, we observe that after increasing the complex concentration, decreasing the pinching, it is we observe that it is also further supporting data of binding with metal complexes with DNA. Antibacterial and antimicrobial activity of my compounds. It is screened against the bacteria and fungi. To give them antibacterial activity, we observe that 2 gram positive and gram negative. Antifungal activity also we using by 2 different fungus like that Rolpe and Microbial Phosinium. The metal complexes, finally it is concluded, but metal complexes show higher the antimicrobial activity compared to ship-based ligands. This is the major activity conclusion of my compounds. Ship-bases are majorly respective mononuclear metal complexes are synthesized and characterized. Based on spectral data, we observed that cobalt to nickel 2 complexes qual-planar geometry versus to cobalt is the octahedral geometry. The interaction of complexes with ctDNA has been investigation, absorption spectra, and fluorescence pitching study. Results reveal that the interaction with takes place in the intercalative mode of binding. Compared to ship-based ligands are exhibit good complexes are high antimicrobial activity against the fungi and bacteria. Thank you.
Thank you, madam, for your clear presentation. Now I request G. Pranaya, research scholar at B.V. Raju Institute of Technology, Narsapur, Medak District, Department of Pharmaceutical Engineering. Madam, please share your paper presentation.
Just a minute, ma'am. I'm trying to share.
Swati madam. Madam, madam, just minimize your window. Chrome tab minimize చేసి మీ PPT ఆన్ చేయండి. అన్మ్యూట్ చేసుకోండి మేడం.
Is it visible, sir, now?
Okay, madam.
Okay. Is it mandatory to on the video, sir? Should I?
Yes, ma'am. Formulation, phytochemical and
Okay, sir. Is it clear, sir?
yes, ma'am.
Okay, sir. Just a minute. Yeah, my student will present, sir.
Okay.
Next. Good morning, everyone. Good morning, everyone. I am Pranaya from BVRIT College. I am presenting about the formulation and evaluation of herbal soaps.
కొంచెం లౌడ్గా మాట్లాడరా?
Okay, sir. In this presentation, I am discussing about the introduction, materials and methodology, evaluation test for herbal soaps, results and conclusion. Firstly, introduction. Herbal soaps are the organic products which are made from natural herbs and ingredients that are beneficial and health. For skin, herbal soaps are made by pure herbs. They are free from chemical and side effects. Most of the commercial soaps contains chemicals that can be harmful to the skin, but the organic handmade soaps with pure essential oils, herbs are the source of some potent pharmaceutical medications. In these herbal soaps, we made two types of soaps. One is Solanium lycopersicum soap. It can rectify the damaged skin and restore its natural health glow. They have anti-angina properties, reduce the skin damage from skin. And another one is Tagetes soaps, one of the most important traditional flower. Due to its antiseptic and anti-inflammatory activity, it helps heal the skin from minor burns and injuries and regenerates new skin cells. Treat chronic skin diseases. Tagetes oil hydrates the skin and locks in moisture to reduce dry skin and kills the bacteria. The materials which are used to made herbal soaps are Solanium lycopersicum powder, Tagetes powder, olive oil, sunflower oil, rose oil, essential oil, coconut oil,
sodium hydroxide pellets, distilled water. The formula for herbal soaps is that actually we, we done with 6 trials. In these 6 trials, fifth and sixth trial was success. Procedure for the preparation of herbal soaps. First, we need to weigh the oils and powders with required quantity. Then, we need to prepare lay solution. The lay solution is prepared. Sodium hydroxide pellets is dissolved in required water. Then, mixing of oils in a beaker. In that beaker, lay solution was slowly added to this mixture. Then it stirred for 20 minutes on magnetic stirrer until soap formation was absorbed. After the plant extract was added, then the solid soap formed was poured into the molds and then left to stand for 24 hours. The soap was allowed to dry for 7 days. Then evaluation test for herbal soaps will explained by my friend Manish.
Good morning to everyone. I am Manisha. Evaluation test for herbal soaps. We done the four steps. pH determination. First, we have to take the sample and dissolve it in the 10 ml of distilled water. Take one drop of sample on pH paper and compare with pH determination pH paper. pH color shades and dissolve and note down the value of pH. Foaming retention test. Take 1 gram of sample and dissolve it in the 10 ml of distilled water. Result minimum heat of 60 degrees. And 5 ml of resulting solution was transferred into a 10 ml of test tube. Pour the 2-3 drops of oil and test tube. Shake for 1 minute using the vortex test tube. Mixture and left for 10 minutes and note down the foaming retention test value. Oil foaming retention test. Take 1 gram of sample and dissolve it in the 10 ml of distilled water and tap water by minimum heat of 60 degrees. 5 ml of distilled water was transferred into a 10 ml of test tube. Pour 2-3 drops of oil and shake well for 1 minute. Kept for side for 10 minutes and note down the value of oil foaming retention test. Antimicrobial test was still processing. Result: pH value was 8 and foam height 7 centimeters after stand for 10 minutes. Oil foaming height 5 centimeters after standing 10 minutes. Antimicrobial test is still in process. Conclusion. The herbal soaps are prepared successfully. It is used for skin kill bacteria. Herbal soaps contain many natural products and it avoids side effects. The preparing soap has good foamability and the pH is within the limits. Thank you.
Thank you, Pauni madam, Pranaya and Manisha. Is there any questions from the participant? Hope there is no further questions.
Thank you.
I request M. Swati, research scholar at Usmania University, to share your presentation on the topic synthesis, structural and characterization of DNA interaction, studies and anti-tumor activity of metals. Madam, please start your presentation. Swati Madam, please start your presentation.
Madam, please unmute, madam. Swati madam, please unmute.
Okay, sir. Sir, is it visible, sir?
Yes, ma'am.
Are you sharing any PPT?
Yes, sir.
But
Is it visible, sir?
no, madam. Share చేయండి. Please go to present now and then select enter screen.
Is it visible, sir?
No, madam.
No, madam.
Madam, please go to present now.
పైన 3 డాట్స్ ఉంటాయి కదా, దానిపైన కింద 3 డాట్స్ కనిపిస్తున్నాయి కదా ల్యాప్టాప్.
మేడం
Yes.
మీట్ అన్మ్యూట్ చేసేట్లో ప్రజెంట్ అవ్వడం చూడండి మేడం. ఒక బాక్స్ లో యారో అబో యారో ఉంటుంది, దాని మీద క్లిక్ చేసి యువర్ ఎంటైర్ స్క్రీన్ సెలెక్ట్ చేయండి.
Sir.
ఎంటైర్ స్క్రీన్ సెలెక్ట్ చేసినప్పుడు మీకు ఒక పాప్ డౌన్ కనబడి దాంట్లో మీ స్క్రీన్ మొత్తం అపియర్ అయింది. దాన్ని సెలెక్ట్ చేసి షేర్ అని క్లిక్ చేయండి.
Okay. Is it visible?
నో మేడం.
స్వాతి, కింద నీకు కనిపిస్తున్నాయి చూడు, ఒక 5 1 2 3 4 5 6 7 కింద కనిపిస్తున్నాయి చూడు, ఒకటి వీడియో.
చూపిస్తాను చూడండి మీకు. మేడం నేను చూపిస్తున్నాను చూడండి మీకు. ఇప్పుడు మీకు నా స్క్రీన్ కనబడుతుందా మేడం?
Sir.
ఇదిగోండి మేడం, దీంట్లో ఇక్కడ మీరు యూట్యూబ్ వీడియో తీసి రైట్ హ్యాండ్ షేర్ యువర్ ప్రజెంట్. నన్ను ప్రజెంటేషన్ మీకు విజిబుల్గా ఉందా?
Sir.
అక్కడ క్లిక్ చేయాలి. మీరు ఒకసారి ట్రై చేయండి. మీరు ట్రై చేస్తే నాకు ఆటోమేటిక్ రిజెక్ట్ చేయాలి.
నువ్వు సిస్టమ్ ల్యాప్టాప్ లోనా స్వాతి?
మేడం ఎన్ని డేస్ మనకి?
లేకపోతే ఆ పీపీటీ నాకు సెండ్ చేస్తావా? నేను ప్రజెంట్ చేస్తాను.
Sir.
స్వాతి,
No, madam.
Okay.
ఇప్పుడు ఓకే. Now it's clear.
Okay, madam. Okay.
Swati, start. You start your presentation. Swati, go to first slide and explain.
Madam, your voice is not audible.
Swati, working under the supervision of Professor Shivaraj sir from Osmania University. My topic is synthesis, DNA interaction studies, and antimicrobial microbial activity of novel base metal complexes. According to the central dogma, which includes the DNA transcription, translation, and from the transcription, the DNA gets transformed into an RNA, and through translation, it gets transformed into proteins, and by disrupting. Is it visible? My topic includes the introduction and synthesis of Shib-bases and synthesis of Shib-base metal complexes, the characterization, DNA interactions, and biological activity. Coming to the introduction, according to the central dogma, the DNA gets transformed into RNA, which later transforms into proteins through translation, and this is the central dogma. The cell undergoes some change, where the normal cell undergoes some changes and transforms into an abnormal cell that leads to the cancer cells. And to treat these cancer cells, neurotoxic the platinum-based anti-cancer agents have been synthesized in the recent decades, and platinum is being ma'am, sir, they have been synthesized in the recent decades due to their modified structurally to. It has become a breakthrough in the research field to synthesize novel antineoplasmic agents, which are nothing but anti-cancer agents. Coming to the topic, the importance of Shib-base includes it has biological applications, and it also includes the oxygen and nitrogen donor atoms, which are helped in the complex formation, and the azomethane linkage is present in these Shib-bases. It mainly helps in the biological activity. Coming to the central metal atoms, metal centers are essential elements in the life which exhibits a greater biological activity with their protein centers, and they also include in the oxygen transport and electron transfer and various biological processes. Coming to the applications, they act as chelating agents, they act as catalysts and dyes, and a myriad of biological activities. The main Shib-bases are prominent in the coordination chemistry due to the presence of azomethane linkage. They have provided opportunity for in myriad applications and also some biological activities such as anti-tumor, antimicrobial, and herbicidal activities. By combining, by undergoing complexation, they bind with the metal, help in the DNA binding interactions through the electrostatic binding. Synthesis of ship bases. Hot methanolic solution of the aldehydes have been added to the 2-methoxyfied trifluoromethyl aniline methanolic solution. They have been and during the reaction it has been monitored through TLC. The reaction has been, the reaction progress is being monitored by the TLC method, and there is after a few hours the resultant recrystallized to get a purified form, and orange crystals have been obtained. These are used for the characterization of further. And these chip bases which have been synthesized have been combined with the metal solutions such as copper, cobalt, nickel. Metal complexes have been formed. These are vibrant colors have been obtained, and these precipitates have been dried and collected in a purified form. They have been, all the complexes and this ship bases are soluble in methanol, DMSO, and all the inorganic solvents, and they are insoluble in water. Coming to the characterization, uh, the ship base which have been synthesized consists of 11 protons. By taking into consideration these peaks, they have been tallied uh, at their particular ppm, and the OH peak is observed at 14.2, and the aromatic region, the protons, 5 protons are present in the aromatic region. They appear in 7.2 to 7.2 region, and the azomethane proton appears at 8.9, and methoxy protons are also present in the ship base, which appear at 4 ppm. And coming to the C13 NMR, and by considering the number of carbon atoms, the peaks have been tallied, and this also confirms the formation of a ship base. And coming to the FTR analysis, this slide represents the ligands along with the 3 complexes, which in the first part includes the ligand, and the remaining 3 are the complexes. The ligand shows broad phenolic peak at 3,464, and at 1622 centimeter inverse, the azomethane proton appears, and at 1125 centimeter inverse, the CO band appears, and this 735, the sorry, these are the peaks appeared in the ligands. There's a shift in the bands towards the lower frequency region, and coming to the cobalt complexes, there appears a broad peak around 3,429, which may be due to the presence of water molecule, and there's also slight shifting from 1622 to 1609 and 1125 to 1128. In addition to that, 507 and 423 peaks are also appear, which might be due to metal oxygen and metal nitrogen moieties. And the copper and the nickel complexes doesn't show any with hydroxy peak due to the absence of water molecule in those complexes, which can be further supported by TG analysis. This is the IR and IR data. And coming to the UV nanometers, this is considered for the ligands and the complexes show the copper and nickel complexes show slight shifting in by considering the pi to pi star and the n to pi star transitions. These bands are appearing. In addition to that, DD bands are also appeared around 500 to 550 nanometers, which might be due to the transitions in the d orbitals. The cobalt shows two T to G transitions. Nickel shows singlet A1G to singlet A to DD transitions. Coming to the ESR analysis, by taking by considering the copper environment, we have calculated the G parallel and G perpendicular and G tensor values, which mainly gives the 2.0477 G parallel value, and the G perpendicular is 2.034, and G tensor value is 1.97. And coming to the A parallel value is 0.0152, and A parallel by G parallel is 134 centimeters. Uh, by, by considering this graph, G parallel is greater than G perpendicular, is greater than G electron values. Due to from this we can consider that the unpaired electron is located in the is localized in the d exponential by taking the doublet B1G as a ground state. If the G parallel value is less than 2.3, it is 2.047. From this, we can confirm this covalent nature of metal ligand moiety is present. And if the capital G value is 1.9, if it is less than 4, negligible interactions are considerable interactions are present between copper metal centers. It is the interactions are present in these copper complexes. From this, we can confirm that from the characterization, we can confirm that the copper and cobalt complex, copper and nickel complexes exhibit square planar geometry, and the copper complexes exhibit cobalt complexes exhibit octahedral geometry. Coming to the DNA interactions, DNA commonly the
Okay. Thank you, madam.
Thank you, madam.
Hope there is no further question.
Hope there is no further
We will move
questions.
on to the last
We will
session
move
of the
on
day.
to the last section of the day.
Now I request P.
Now I
Kirtana
request
madam,
P. Kirtana
lecturer in
madam,
Department of
lecturer
Chemistry.
in Department of Chemistry, to propose vote of thanks.
Thank you, Anitya madam. Thank you, Anuja madam. It's my privilege to propose the vote of thanks for the fourth day of 5-day international webinar. Respected correspondent, principal, vice principal, colleagues, our most valued resource person of the day, Dr. P. Jyoti, and dear participants, on behalf of the entire fraternity of JMJ College for Women, Autonomous Tenali. It has been a such as honor to be a part of this wonderful event. On behalf of the organization, I would like to express my heartfelt gratitude to all esteemed delegates of the webinar for their presence and contribution to make this webinar a great success. At first, I extend my gratitude to our Honorable Speaker of the Day, Dr. P. Jyoti, to take out time for her busy schedule to grace the event and sharing her valuable thoughts and knowledge with us. Thank you, ma'am, for your interesting and highly informative and wonderful session of the day. We thanks to research scholars for their paper presentation and sharing their knowledge to us. I express my deep gratitude to our correspondent, Dr. Sister Teresa Magade, for supporting us to organize this webinar. I express my sincere thanks to and special thanks regards to our beloved principal, Dr. Sister Shaini KP, for giving us all the guidance and help to conduct the webinar for the good community of at large. I would like thank to our beloved Vice Principal, Sister Mary Sarada, Dr. V. Sumalata, the convener of International Webinar, K. Bhavani Devi, Organizing Secretary of Webinar, for their support and assistance. My sincere thanks to all the members who participated in the webinar and made it grand success. Thank you, one and all.
Thank you, madam. Thank you, one and all. We will meet you tomorrow at the same time. Thank you.
Hello? Hello, madam?
Yes, sir.
Bhavani, madam?
హలో సార్
మేడం ఇవాళ అయిపోయిందా
సార్ రేపు కానీ పెట్టాము సార్. ఈ రోజు నలుగురు అయిపోయారు సార్, అందుకని రేపు పెడదాం సార్. మళ్ళీ
అదే రేపు
రేపు ఎర్లీగా పెట్టేసేస్తే అంటే మీకు కాల్ చేశాను, మీకు 2-3 టైమ్స్ కాల్ చేస్తే మీరు లిఫ్ట్ చేయట్లా.
క్లాస్ లో ఉన్నట్టున్నానండి.
అందుకని మీరు బహుశా ఈ రోజు రెడీగా లేరేమో, అందుకని కాల్ లిఫ్ట్ చేయట్లేదేమో. రేపు పంపించాను సార్.
పేపర్ వచ్చింది కదండి?
వచ్చింది సార్.
సరేలేండి.
రేపు నేను మీకు కాల్ చేస్తాను సార్ ఎర్లీగా.
సరే.
భవాని మేడం, రేపు టైమింగ్స్ ఏంటి?
10కి సార్.
రేపు టైమింగ్స్
10 సార్, మార్నింగ్ 10కి సార్.
మార్నింగ్ 10. ఓకే అమ్మా.
ఓకే సార్, థ్యాంక్ యూ సార్.
సరేండి. రేపు కష్టం కదా రేపు?
లేదు సార్, రేపు కూడా నలుగురు ఉన్నారు సార్.
సరే. 10:30 11కి అవుతుందండి. 11కి అవుతుందా?
11కి రెడీగా ఉండండి మీరు.
సరే.
ఓకే సార్, థ్యాంక్ యూ.